The most expensive software on your computer may be the software you were told was free. Windows 11 arrived on millions of machines without a traditional checkout page. Eligible? Windows 10 users saw an upgrade banner, clicked a button, waited through a restart, and entered a redesigned desktop without handing Microsoft another dollar. That felt generous. It also felt inevitable. Windows 10. Support ended, hardware vendors moved on, and the operating system that runs most of the world's personal computers became the path of least resistance. But free does not mean costless. The real price of Windows 11 is not hidden in one dramatic file, one secret microphone process, or one mythical switch that sends every keystroke to a corporate server. The truth is more sophisticated than that, and therefore more difficult to dismiss. Windows 11 is the front door to an ecosystem built around identity, cloud storage, subscriptions, search, advertising, recommendations, app distribution, artificial intelligence, and a continuous flow of diagnostic information. The operating system is no longer just a product installed on a machine. It is a permanent relationship between the machine, its owner, and Microsoft services. That relationship begins with a simple psychological trick. When people pay directly for software, they evaluate the transaction. They ask what they own, what the company receives, how long the license lasts, and what happens when support ends. When the upgrade appears free, that moment of negotiation disappears. The user does not feel like a customer entering a contract. The user feels like a passenger accepting a routine update. And that is where the real cost becomes almost invisible. Microsoft still earns money from Windows licenses. Computer manufacturers pay to ship Windows on new devices. Businesses pay for commercial editions, management, security, and cloud services. Retail licenses still exist. So the claim that Microsoft simply abandoned license revenue and replaced it with personal data would be inaccurate. The business model is not that simple. It is more powerful because it is layered. The license gets Windows onto the device. The device creates the relationship. The relationship creates recurring opportunities. A Windows desktop can promote OneDrive when local storage fills up. It can recommend Microsoft 365 when a document is opened. It can direct searches through Bing, launch results in Edge, place news and interests inside system surfaces, suggest apps in the Start menu, display offers inside Settings, connect the user to a Microsoft account, and introduce Copilot as the default gateway to artificial intelligence. None of these elements needs to be sinister in isolation. Together, they transform the operating system from a neutral tool into a distribution platform. Distribution is enormously valuable. If Microsoft controls the first screen you see, the search box you use, the account you sign into, the browser installed by default, the cloud folder offered during setup, and the notifications that appear beside the clock, it does not need to force every purchase. It only needs to shape the path of least resistance. A small percentage of users accepting a storage plan, a Microsoft 365 subscription, a game service, an Edge default, or an advertising recommendation becomes meaningful when the platform operates at global scale. Telemetry helps measure and optimize that system. The word telemetry sounds technical and harmless. In engineering, it usually means information sent from a remote system, so developers can understand how that system behaves. A modern operating system has legitimate reasons to collect diagnostic data. Microsoft needs to know whether an update causes crashes on a particular graphics driver, whether a security feature fails on a certain hardware configuration, whether a battery problem is widespread, or whether a new build creates boot failures. Without diagnostic information, fixing a platform used across millions of combinations of processors, drivers, applications, and peripherals would be slower and less reliable. That legitimate need is important because it is often used to shut down the entire privacy conversation. Critics say Windows sends data. Defenders answer that diagnostics keep Windows secure. Both statements can be true. The real question is not whether all telemetry is evil. The real question is how much data is collected, which parts are necessary, which parts are optional, how clearly the user understands the distinction, and whether the operating system uses the same relationship to deliver recommendations, advertising, and commercial nudges. Microsoft divides Windows Diagnostic Collection into required and optional categories. Required data includes details about the device, its configuration, capabilities, update readiness, reliability, and conditions that may interfere with updates. Optional diagnostic data can go further, including broader information about how features and applications are used, enhanced error reporting, and other activity intended to improve products. When tailored experiences are enabled, diagnostic information can also support personalized tips, recommendations, and advertisements. That distinction matters. A crash report helping Microsoft repair a broken driver is not the same as a system learning which applications you launch, so it can personalize parts of the interface. A security signal identifying malware is not the same as an advertising identifier that allows apps to show more personalized ads. A connection used to validate a license is not the same as a connection used to fetch suggested content. Yet, to the average user, all of these activities disappear behind the same spinning dots, background services, and encrypted network traffic. Windows does not present a live invoice every time data leaves the device. It simply operates. Behind the desktop, the connected user experiences and telemetry component manages structured diagnostic events and logs. Windows error reporting can send crash information. Separate Microsoft applications, including Edge and Microsoft 365, may have their own diagnostic controls. OneDrive communicates with cloud services. Windows Spotlight retrieves images, tips, account notices, and suggested content. The Microsoft Store contacts licensing, update, catalog, analytics, and security systems. Defender can use cloud-based protection. Search and widgets may contact online services. Each connection has a stated function. Each function can be defended on its own. The privacy problem emerges from accumulation. A user may disable optional Windows diagnostics and still have data flowing through Edge, Office, OneDrive, the Store, Search, widgets, cloud protection, or other installed applications. Turning off one setting does not convert the machine into an offline appliance. Windows is a collection of connected components, and many components have separate policies, permissions, and business purposes. This is why simplistic debloating videos are so dangerous. A creator runs one script, deletes a collection of packages, disables a dozen services, blocks a list of domains, and announces that Windows has been made private. The computer may look quieter in Task Manager, but privacy is not measured by the number of services removed. A script can disable telemetry and also break updates, store licensing, notifications, search, cloud protection, device management, application dependencies, or future feature upgrades. It can create a machine that feels clean for a week and becomes unstable 6 months later. Microsoft's own endpoint documentation reveals the trade-offs. Block a licensing endpoint and activation or app licensing may fail. Block Microsoft account endpoints and account sign-in stops working. Block Defender cloud services and cloud-based protection disappears. Block Store endpoints and applications may not install, update, or have malicious licenses revoked. Block push notification services and mail synchronization, management, or notifications can fail. Block settings infrastructure and some applications may stop receiving configuration data. This does not mean users are powerless. It means sovereignty requires precision. The first step is to stop treating privacy as a single switch. Privacy is a configuration process. It begins with understanding what the system is doing, deciding which connected features are useful, and removing the ones that do not serve you. Start with the Windows privacy settings, not a random script from an anonymous repository. Open privacy and security, then review diagnostics and feedback. Turn off optional diagnostic data unless you have a clear reason to provide it. Disable tailored experiences, so diagnostic information is not used to shape personalized tips, advertisements, and recommendations. Turn off improved inking and typing if you do not want that information contributing to Microsoft's language systems. Reduce feedback requests. Use the option to delete diagnostic data associated with the device where available. Then inspect general privacy settings. Disable the advertising ID if you do not want apps using it for personalized advertising. Windows makes clear that turning it off does not remove advertisements, it reduces personalization. Disable app launch tracking if you do not want Windows using your launch history to improve start and search results. Turn off suggested content in settings. Disable access to the language list for locally relevant website content unless you find it useful. These settings do not make the computer invisible. They change the default relationship. Next, review application permissions, one category at a time. Location, camera, microphone, notifications, contacts, calendar, call history, email, tasks, messaging, radios, file system access, and background application permissions should not be granted by habit. A desktop operating system often inherits years of approvals. Applications installed for one task remain authorized long after the user forgets why they were installed. Revoke what is unnecessary. Then examine account architecture. A Microsoft account offers real benefits. It can synchronize settings, support device recovery, connect licenses, integrate OneDrive, simplify store purchases, and provide account-based security features. But it also creates a durable identity layer across services and devices. Activities that were once isolated on a local computer can become associated with the same account used for email, cloud storage, browsing, subscriptions, gaming, and AI services. For users who do not need that integration, Windows still provides a path to switch from a Microsoft account to a local account after setup. That choice reduces some synchronization and convenience, but it also creates separation. The correct decision depends on the threat model. A family laptop, a corporate workstation, a gaming PC, an offline editing machine, and a research computer do not need identical configurations. The arrival of Recall on supported Copilot Plus PCs sharpens this boundary. Recall is not ordinary diagnostic telemetry. Microsoft describes it as a local feature that saves snapshots so users can search through past activity. And the company provides controls to pause it, disable snapshot saving, filter applications and websites, and protect setting changes with Windows Hello. That distinction matters because critics often collapse every form of data processing into one accusation. A locally stored index is not automatically an upload to an advertising server, but local processing can still create privacy risk. A searchable history of what appeared on a screen may expose conversations, documents, financial details, client work, or private browsing to anyone who compromises the account or gains authorized access to the machine. Sensitive information filtering reduces risk. It does not eliminate the need for judgment. The correct question is not only where data travels, it is also what data the computer retains, how long it remains available, who can unlock it, and whether the feature serves the owner's purpose. This is the direction of modern operating systems. More observation, more indexing, more personalization, and more assistance. Some processing happens in Microsoft's cloud. Some happens locally. Some is necessary for security. Some is optional convenience. Treating all of it as identical weakens the privacy argument. Mapping each data flow makes the argument stronger. Privacy without a threat model becomes theater. Ask what you are protecting. Are you trying to reduce personalized advertising? Are you trying to prevent cloud synchronization of files? Are you trying to minimize diagnostic data? Are you trying to isolate sensitive client work? Are you trying to protect against account compromise? Are you trying to stop the operating system from becoming a sales channel? Each goal requires different controls. A user concerned mainly about advertisements should disable the advertising ID, tailored experiences, recommendations, widgets, and personalized ad settings associated with the Microsoft account. A user handling confidential files should focus on local storage, OneDrive configuration, application permissions, backup destinations, encryption, browser sync, and account security. A user building a high isolation workstation may need Windows Enterprise policies, firewall rules, controlled update infrastructure, application allow listing, and network monitoring, rather than consumer-grade toggles. This is where the phrase telemetry is the new currency becomes useful, but only if we define it carefully. Data does not need to be sold as a spreadsheet with your name on it to create economic value. Behavioral information helps a company understand which features people use, which prompts they ignore, which defaults they change, where they abandon a setup flow, which recommendations produce engagement, and which services deserve more prominent placement. Aggregated information can guide product design. Account-linked activity can personalize experiences. Advertising systems can use interaction data under their stated policies. Search behavior can improve search products and advertising performance. Diagnostic trends can reduce support costs and prioritize engineering work. Information becomes valuable because it reduces uncertainty. For a software company, uncertainty is expensive. Engineers can build the wrong feature. Marketers can promote the wrong service. Product teams can place a button where nobody clicks it. A subscription prompt can appear at the wrong moment. Telemetry turns millions of individual actions into a map of what the user base actually does. That map can improve the product. It can also improve monetization. The two goals are not mutually exclusive. Microsoft's financial reporting makes the wider strategy visible. Windows licensing remains a revenue stream, but Microsoft's strongest growth has increasingly come from cloud services, Microsoft 365 subscriptions, advertising, and other recurring businesses. The operating system sits at the intersection of those businesses. It can introduce users to them, authenticate them, surface them, and reduce the friction of adopting them. So the free Windows 11 upgrade is not best understood as charity. It is customer acquisition. Microsoft does not need every upgraded user to purchase a new license. The company benefits when the user stays inside the Microsoft environment, searches with Microsoft services, stores files in Microsoft clouds, subscribes to Microsoft 365, uses Edge, buys through the store, plays through Xbox services, interacts with Copilot, or simply remains reachable through system-level recommendations. The upgrade preserves the platform relationship. MA and platform relationships are difficult to escape because they are built from convenience. OneDrive appears inside File Explorer. A Microsoft account unlocks synchronization, Edge imports browser data, Search reaches the web, the store manages applications, Copilot offers assistance, Defender contacts cloud protection. The user is not dragged into the ecosystem by one chain. The user is pulled by 100 small conveniences. This is why consent inside an operating system is complicated. Technically, many settings can be changed. Practically, most people never change them. They click through setup screens while trying to reach the desktop. They accept recommended options because declining requires more attention. They keep defaults because defaults usually work. They sign into the same account because the system encourages it. They enable backup because losing files is frightening. They leave recommendations on because the switch is buried several menus deep. Consent obtained through exhaustion is not meaningful control. A privacy-respecting design would make the consequences of each choice obvious. It would separate security diagnostics from product improvement data. It would distinguish operating system reliability from advertising personalization. It would explain which data remains required after optional collection is disabled. It would avoid resetting preferences after major updates. It would make a local-first setup as visible as a cloud-first setup. It would give users one clear dashboard showing every Microsoft component that transmits information and the purpose of each connection. Windows has moved toward greater transparency in some areas. The Diagnostic Data Viewer allows users to inspect diagnostic events being sent from the device. Microsoft publishes extensive lists of required and optional diagnostic fields. Enterprise administrators can use group policy and mobile device management to configure collection. Microsoft publishes service endpoints and describes what may break when traffic is blocked. That transparency deserves recognition. It also reveals how complex the system has become. Open the Diagnostic Data Viewer and the myth of a single telemetry stream disappears. What you see is a language of event names, fields, identifiers, component states, reliability measurements, and technical metadata. The information may be documented, but documentation is not the same as accessibility. A normal user cannot be expected to audit hundreds of events and decide which ones are proportional. Transparency without simplicity still favors the platform. This is why advanced users turn to registry policies, group policy, PowerShell, firewall rules, DNS filtering, and debloating utilities. These tools can help, but they should be used as controlled instruments, not ideological weapons. Registry changes are powerful because Windows exposes many policy settings through registry-backed configuration. A carefully documented policy can disable consumer experiences, reduce diagnostic levels where the edition supports it, turn off tailored content, restrict cloud features, control search integration, or prevent certain suggestions. Group policy is usually safer than manually editing random registry keys because it makes the administrative intent clearer and easier to reverse. But not every registry key found online still works. Windows changes, policies are renamed, deprecated, restricted by addition, or overridden by newer components. A tweak written for Windows 10 may behave differently on Windows 11. A setting that works in Enterprise may be ignored in Home. A script that removes a provisioned application can affect only new user profiles while leaving existing packages untouched. Another script may delete dependencies needed by features the user actually wants. The correct method is reversible hardening. Create a restore point or full system image. Export relevant registry keys before changing them. Use documented policies whenever possible. Change one category at a time. Reboot. Test Windows Update. Microsoft Store updates, printing, audio, Bluetooth, camera access, sleep, search, Defender, activation, and the applications you depend on. Record every modification. If a privacy guide cannot explain how to undo a change, it is not a serious privacy guide. Debloating should follow the same discipline. Removing unwanted applications is reasonable. If you do not use Xbox components, consumer news apps, Clipchamp, Teams for personal use, or other bundled software, uninstalling supported packages can reduce clutter and background activity. Disabling widgets can remove a content surface you never requested. Turning off Windows Spotlight and suggestions can reduce promotional material. Preventing unnecessary applications from running at startup can improve performance and reduce network noise. But deleting core components to win a screenshot of low process counts is not sovereignty. It is fragility. A sovereign system is one you understand, one you can maintain, and one that does not collapse when the next cumulative update arrives. Network monitoring adds another layer of truth. Instead of assuming every connection is surveillance, use tools that show which process opened a connection, where it connected, how often it transmitted, and what happened after a setting changed. Windows Resource Monitor, firewall logs, DNS logs, packet capture tools, and endpoint monitoring can reveal patterns. Encrypted traffic may hide content, but destinations, timing, process ownership, and frequency still provide useful evidence. Test before and after. Turn off optional diagnostics and observe the change. Disable widgets and compare network activity. Sign out of OneDrive and confirm synchronization stops. Switch off personalized experiences and inspect related settings. Remove an application and verify that its scheduled tasks and background components are gone. This approach replaces fear with measurement. It also exposes an uncomfortable fact. Some Windows communication cannot be eliminated without sacrificing functionality. A secure modern system needs updates. Defender Cloud Protection can improve detection. Smart Screen can warn about dangerous downloads and websites. Certificate validation may require network access. Time synchronization matters. Activation and store licensing rely on servers. Cloud backup protects against disk failure and ransomware. Privacy is not achieved by cutting every wire. It is achieved by deciding which wires are justified. The strongest privacy configuration is therefore not the one with zero network activity. It is the one where every remaining connection has a purpose the owner understands and accepts. For some users, that may still be Windows 11. A hardened Windows system can be practical. Use a local account where appropriate. Keep BitLocker or device encryption enabled. Maintain security updates. Use a standard user account for daily work. Restrict application permissions. Remove unused software. Disable optional diagnostics. Add personalization, tailored experiences, suggestions, and cloud features you do not use. Configure Edge separately or use another browser with its own privacy controls. Audit Microsoft 365. Privacy settings separately. Review OneDrive rather than assuming that changing a Windows toggle controls cloud synchronization. Keep Defender protections unless you replace them with a credible alternative. For other users, the conclusion may be different. If the operating system's connected design conflicts with the purpose of the machine, use a different architecture. A Linux workstation can offer greater transparency and control, though it introduces its own maintenance and compatibility trade-offs. An offline Windows machine can be isolated for specific legacy applications. A virtual machine can contain software that requires Windows. Separate user profiles or separate physical devices can prevent one account from becoming the identity center for every activity. Sovereignty sometimes means refusing to make one computer do everything. The deepest issue is not that Windows 11 secretly watches every movement. That claim is too broad, too theatrical, and too easy for Microsoft to dismiss. The deeper issue is that the operating system has become an active participant in the commercial relationship between the user and the company. It measures, it recommends, it synchronizes, it authenticates, it promotes, it connects. It improves itself using information from the machines on which it runs.